There we go. All right, cool. Start again. So yeah, I'm really excited to be here. I am here tonight because of the book that I wrote that came out this spring titled Flight Paths. You can see it here on the screen. And as was said in that great introduction, it's about the history and the science behind how we know what we know about bird migration. I have spent the last several years of my life immersed in this topic. I have read more scientific papers than I could possibly count. I have talked to dozens of scientists, including not only ornithologists, but a really surprising number of computer scientists and electrical engineers and folks like that. I've joined a few of those ornithologists in the field when they were carrying out their research. And it's really been a privilege. I love that my whole job these days is basically telling stories about birds and ornithology. I still feel like the scientists who I feature in this book are the real experts on the topic, not me. And I'm just here to share their stories and hopefully bring what they're doing to a wider audience. And this is a really fun job to have because really there are so many good stories to tell about bird migration. So these are just a few of the amazing migrators whose stories appear in my book. On the left, that's the bar-tailed godwit. Some of you may be familiar with this bird's migration in fall. These guys make a nonstop flight from Alaska clear across the Pacific Ocean to New Zealand and other parts in that area without stopping. So they make a flight clear across the Pacific nonstop, which is just mind-blowing to me. In the middle here is the bar-headed goose. These guys make the highest altitude bird migration in the world. They fly over the tops of the Himalayan mountains every year while they're going back and forth. And on the upper right, we have the blackpoll warbler. These little guys, again, some of you may be familiar with them when they're heading south in the fall to get from New England to their wintering grounds in northern South America. They launch themselves out over the ocean and just spend 3 days flying over the open waters of the Atlantic, which maybe sounds less impressive than the bar-tailed godwit spending a week flying across the Pacific, until you remember that a bar-tailed godwit is about the size of a football and a blackpoll warbler weighs about the same as a ballpoint pen. So it's just astounding. But for me, what fascinates me just as much as what migrating birds do and how they do it is how we figured all of this out. So that's what my book is really about, and that's what I'm here to talk about tonight. Before I really dive in, I want to just briefly give a little bit more background on me and how my book came to be. So I was in the past working full-time for the American Ornithological Society, which is the big professional organization for bird scientists in the US. They do stuff like give out research grants and put on conferences, things like that. I was their one-person communications department. So I wore a lot of hats, but a big part of what I did was promoting the new ornithology research that was being published in their 2 peer-reviewed journals, which are what you can see on the screen here. They were then called the Auk and the Condor. They've since changed the names to less interesting ones. And so I was reading a lot of new scientific reports. I was turning them into blog posts, press releases, things like that to try to engage the public. I don't know how many of you are familiar with the structure of a scientific paper, but they all follow the same basic format. They start with the introduction, where the researchers talk about what question they were trying to answer and why it's important. And then there's the methods, where they explain step by step exactly how they did it. And then there's the results and discussion, where they explain what they found and again, why it matters, why it's interesting. And I was reading all these papers and I kept getting sucked in to the part that I think a lot of people skim over to get to the good stuff, which is the methods, the how of all these studies. I didn't know, or if I had learned as an undergraduate taking ornithology a long time ago, that you can study bird migration using weather radar. You can study it using nocturnal flight calls, putting out microphones to passively record the calls of birds passing overhead. You can study it by analyzing rare hydrogen isotopes in bird feathers. I'm not even going to get into that one tonight, but it's just wild. And so I started thinking, how did we figure all of this out? And who figured all of this out? And what is even the science behind how this works? And so when the COVID pandemic began, I ended up leaving that job and I decided to turn this idea into a book proposal, which became the book that was published this spring. So this is the table of contents from the book. If we wanted to, we could play a guessing game of trying to having you guys guess which chapter title goes with which topic. But basically, I go chapter by chapter through each of the major techniques that have been developed to study migration over the last century plus, beginning with the origins of bird banding in North America in the early 20th century and going all the way up through high-tech stuff like miniaturized tracking devices and genetic sequencing and that sort of thing. So I cover a lot of ground in the book, way more than I could possibly cram into a 45-minute book talk. So when I thought about how I wanted to go about adapting this into a talk, I decided that the best way to do it would just be to sort of zoom in on 3 of my favorite stories from the book. So that what I'm going to do this evening is share just 3 of the many stories in the book of 3 of these sort of interesting characters who came up with creative new ways to study bird migration. And my hope is that you will come away from this evening with a new appreciation of all the hard work and creativity that went into uncovering every gee whiz fact that you ever hear about bird migration. So the first tactic for figuring out what migratory birds are doing that I want to talk about is one that I had not even heard of before I began doing the research for this book, and this is moon watching. So most birds, or at least most songbirds, migrate at night, which means if you want to know what they're doing, you can't just look up and see them because in addition to the fact that they're flying pretty high overhead, it's also dark. So you need to get a little creative. And today we have all sorts of tools like radar and satellite telemetry to help us spy on these night migrating birds. But before any of that technology was developed, this guy, whose name was George Lowry, came up with a really clever way to do it using just a telescope. So George Lowry was born in Louisiana in 1913, and he was fascinated with birds from the time that he was a young child. He finished his master's degree from the University of Louisiana in Baton Rouge in 1936, and he stayed on there for the rest of his career as an instructor and an ornithologist, and he founded LSU's Museum of Zoology, which is still going strong today. Now, being fascinated by birds and growing up along the coast of Louisiana, George Lowry would have been very familiar with the phenomenon of migratory fallout. This is when birds that are crossing the Gulf of Mexico, going north on their spring migration, they have to cross this long stretch of open water. And then depending on the weather conditions, sometimes they basically just fall out of the sky en masse at the first bit of land that they see. So you can get these incredible concentrations of every different sort of migratory songbird you can think of, just like dripping out of the trees along the coast. And although there wasn't any way to prove it with the techniques that existed at the time, a lot of ornithologists in the early 20th century, George Lowry included, thought that it was likely that migrating birds crossed over the open water of the Gulf of Mexico on a regular basis, that was just a normal part of the life of migrating birds. But then in the 1940s, this biologist named George Williams, both of these guys are named George. I apologize. It was a popular name for ornithologists in the mid 20th century. So we had George Lowry, and now along comes George Williams, who says, wait a minute, this doesn't make any sense. Why would these birds voluntarily fly over hundreds of miles of open water when Mexico is right there? Basically, he was like, guys, they must be going up the coast of Mexico. They got to be there. We're just not looking hard enough. It's the only thing that makes sense. Now, George Lowry, back to George number 1, having seen the evidence of trans-Gulf migration with his own eyes, was really annoyed about this. And he started casting about for a way that he could prove that George Williams was wrong and that large-scale trans-Gulf migration was a real phenomenon. And so he was thinking about how he might do it, how he might prove Williams wrong. And he remembered some really quirky ornithology papers that he'd read from the turn of the 20th century, where ornithologists had described looking at the full moon through a telescope during bird migration and being able to see the silhouettes of these night migrating birds passing in front of the moon. And he thought, Lowry thought, that's interesting. I might be able to do something with that. Luckily for him, there was an astronomy professor also at LSU at this time who happened to be really into birds as a hobby. So George Lowry and this astronomer put their heads together and they came up with a set of equations that would let Lowry take a raw count of the number and direction of birds passing in front of the moon in a given amount of time and do some math and turn that into an estimate of the total number of birds crossing an imaginary 1 mile line on the Earth's surface every hour. Now, this is pretty abstract, I admit, but basically what it boils down to is Lowry had a tool now to compare how much bird migration was happening at one time and place with how much bird migration was happening at another time and place. And there'd never really been a good scientific quantitative way to do that before. Lowry dubbed this the migration traffic rate, and he thought that with it, he finally had a tool to demonstrate the volume of birds passing over the Gulf during migration. So April 1945, George Lowry packs up a telescope, gets on a boat that is heading across the Gulf of Mexico for a port on the Yucatan Peninsula to take his big shot at proving George Williams wrong. The first night, he goes up on deck. He's so excited. He's going to do it. Sets up his telescope, points it at the moon, looks through the eyepiece. Lowry had no experience at sea. He had not anticipated the problem that when he looked in the eyepiece on the deck of this boat, the moon would be bobbing up and down, in and out of sight with the waves, so that there was no way that he could get a good count of birds. But Lowry was not a man who gave up easily. He was undeterred. He spent the rest of the crossing of the Gulf like recording every bird that he saw fly past the boat. And finally, they got to the Yucatan and they docked in this port where the waters were somewhat calmer. And so he tried again, set up his telescope, pointed it at the moon, rising over the Gulf. And in 45 minutes, he tallied 12 birds. That may not sound like a lot, but when he did the math, this worked out to more than 3,700 birds passing over an imaginary 1 mile line extending out into the Gulf every hour. So Lowry had just collected the first hard numerical evidence that large-scale trans-Gulf migration was real. Take that, George Williams. Now, Lowry knew he was onto something. He was just getting started. His next big idea for moon watching was that he could scale it up. He could recruit volunteers from all across North America to help collect this kind of data. Today, we would call this citizen science or community science, and there's a whole chapter in my book just about how community science has contributed to our understanding of bird migration. In the 1940s and 50s, those terms hadn't been coined yet. Lowry just knew that he had hit on a method that had the potential to reveal migration patterns at the scale of the entire continent for the first time. But this was too big a job for one man, and luckily for George Lowry, right around this time, an enthusiastic young grad student named Bob Newman arrived at the LSU Museum of Zoology. So again, this is Lowry on the left, Bob Newman on the right. That is clearly not enthusiastic young Bob Newman, newly arrived as a graduate student, but it turns out that at least in the pre-smartphone era, people didn't get a lot of photos taken of them until later in their career when they became famous. So I have no photos of young unknown grad student Bob Newman. But so Lowry on the left, Newman on the right. Like Lowry, Newman ended up staying on at LSU for the rest of his career. And these two men formed a working partnership that lasted all the way until Lowry's death in the 1970s. They both passed away decades ago, so I was not able to talk to either of these men when I was researching my book, but I did get to talk to an ornithologist now in his 80s who worked with both of them when he was a graduate student. He was kind enough to share his memories of these two men, and my impression is that in a lot of ways, they couldn't have been more different. They became sort of the odd couple of ornithology. Lowry was an old school gentleman naturalist who I think would have been right at home in the 19th century. He wore a suit and tie for field work, and he, organized expeditions into the jungle to gather new specimens for his museum. He was a workaholic who would go home to eat dinner with his wife and then sneak back into the office in the evening to get in a couple more hours of work. Newman was a jokester. He had a reputation for his sense of humor. And he also approached problems a lot more like a modern scientist. He taught himself statistics before that was a common skill for zoologists, did not need to know stats to be a biologist at this time. And he made it a personal mission to keep up with the latest bird migration research being published all over the world. And together, these two men came up with a plan to collect a snapshot of migration activity across the entire continent during a single week in October. No one had ever tried anything like this before. This was basically before computers. There might have been a few primitive computers in North America at the time, but these two guys definitely did not have access to them. It was definitely before the internet. And so to pull this off, they spent literally sometimes 12 hours a day handwriting personal letters to hundreds of potential volunteers all over the country, targeting local Audubon chapters just like you guys, explaining the goals of the project and what would be required of data collectors and the special contribution that each participant would be making to science. They eventually recruited 2,500 volunteers in 325 locations from Canada to Panama, who were going to point their telescope at the moon all at the same time. To ensure that the data that they got back was as high quality as possible, they even took the step of printing up a how-to pamphlet to mail out to all their participants, which included some helpful illustrations on how to keep yourself comfortable for long stints of staring up at the moon. This is an actual illustration from one of their how-to pamphlets. I am not kidding. Knowing that Bob Newman had a reputation for his sense of humor, I can't decide if this one was meant to be funny or if it was just the 50s. But either way, finally in fall 1952, telescopes swung into action across North America. People filled out their data sheets, they mailed them off to Louisiana, and now as observations flooded in from every corner of the continent, and paper data sheets were stacking up higher and higher and higher on their desks, Lowry and Newman realized that they had another problem, which they probably should have given more thought to ahead of time, which was how to analyze all that data. Again, no computers. This was before most zoologists even had any training in statistics. Now they needed to calculate the average direction and volume of bird migration from hundreds of locations. They needed to look up data on temperature and wind and the movement of cold fronts for each of these locations because they wanted to look for connections between bird migration patterns and the weather. They needed to look for those patterns, and then they needed to depict all of this on easy to interpret maps, which they would have to draw by hand. It took them 14 years. Finally, 1966, their magnum opus appeared in the ornithological journal, the Auk, which is one of the same ones that I would be working for about 50 years later. They titled it A Continent-Wide View of Bird Migration on 4 Nights in October. And it was full of these really striking, painstakingly crafted maps where they used arrows colored red, white, and black in different sizes to indicate the volume and the direction of migration at locations across the continent on the nights of October 1st through 4th, 1952. You could do moon watching for a couple nights on either side of the actual full moon. In the Midwest and East, you could see these massive migratory flights that spanned multiple states with reports from many locations that were remarkably consistent on how many birds were passing over and what precise direction they were heading in. You could see that favorable winds and the movement of cold fronts both clearly affected migration patterns across the continent, with the heaviest migration occurring in front of advancing cold fronts. I think those gray swoops on the map are the cold fronts. Any of you who like to check the weather forecast during migration now to try and guess when the next big wave of birds is going to hit your area are probably familiar with this idea of migrants riding advancing weather fronts. But to see this at such a large scale was totally new at the time that this was published. I feel like today, when we're so used to seeing, satellite images of the Earth and stuff, it's almost hard to imagine how groundbreaking this must have been. This paper was a blockbuster. It was 40 pages long. It influenced studies of migration for generations, or at least for decades, let's say. It was also the last moon watching paper that Lowry and Newman would ever publish together, because all of this work was about to be made almost entirely obsolete by the rise of a new technology being developed by one of their students, which was radar. So I'm sure some of you might have seen an image like this before. This was taken from the nationwide weather radar system, the same one that you see images from on the Weather Channel with the green and orange blobs to show you where rainstorms are. And you can see some rainstorms over on the East Coast on this map. But I'm sure some of you know what all of those round blobs down the middle of the continent are here. Those are birds. So they generally filter migrating birds and any other distractions out of the radar images that they use for TV weather reports. But birds actually show up really well on radar. It's the water in their bodies reflects the radar waves. Actually, side note, swarms of insects show up on radar too because of the chitin in their exoskeletons. It's really cool. And during migration, big waves of birds moving across the continent show up as these donut-shaped blobs that you can see here. Basically, what's happening is each of those blobs is the field of view of one individual radar station. And as the birds lift off in huge numbers at dusk, they just saturate the field of view of the radar. And so all you see is this round, blobby thing. So when people first started using radar in a big way, it hadn't really occurred to anyone yet that they might pick up birds. Because of course, when radar first really came into use, they weren't looking for birds and they weren't looking for storms either. They were looking for airplanes. Radar really first came into widespread use in World War II. So to get technical, just for a moment here, radar stands for radio detection and ranging. The way that it works is a special radio transmitter beams out radio waves, and as those waves bounce off of objects in their path, some of their energy is reflected back to the radar equipment. And how much energy comes back and the angle that it comes in at tells you something about the size and distance of any objects that are out there. It's basically like sonar or echolocation, but with radio waves instead of sound waves. So scientists had worked out the basic principles of this by the 1930s. And so by the time World War II officially broke out, Great Britain had built a network of radar stations all up and down their coast as an early warning system against any Nazi planes arriving from the mainland. But pretty much as soon as these new radar stations were operational, they started seeing some weird things. So planes pretty much plodded along at consistent speeds and trajectories, but they were seeing these weird signals that appeared and disappeared at random and changed direction and zipped around. This may be apocryphal, but supposedly at one point a red alert was sounded and British fighter planes were urgently ordered into the air to intercept strange signals heading across the English Channel, only to get up into the sky and find nothing there. And exasperated radar operators started calling these things radar angels. Now you guys see where this is going, of course. So while all this was going on, this guy, whose name was David Lack, had been teaching science at a secondary school in Devonshire in southwestern England. Again, he was a young man at this time. This is the same principle of people didn't get photographic portraits taken of themselves until later in their careers. David Lack didn't know it yet, but he was about to become the father of the discipline that would eventually become known as radar ornithology. Now, Lack had always been interested in birds. He studied ornithology when he was a student at Cambridge. And in 1938, he took a year off from his teaching job to travel to the Galapagos Islands to study Darwin's famous finches there. He got back to the UK just as war was breaking out, and Lack later wrote a short memoir about the early years of his career, so I'm gonna tell you in his own words what happened next when young David Lack arrived back in England on the brink of war. I had become a pacifist at the age of 17. He had signed a pledge to an anti-war organization. And in the autumn of 1940, I decided that I ought to leave my job at the school to work with a pacifist unit. I spent a trial night in the East End of London during heavy raids, but was so put off by the pacifists' earnest attitudes and so excited by the flashes and bangs that I was immediately converted from pacifism. A month later, the Central Register for Scientific Workers sent me to interview for an unspecified job. As a biologist, you will of course have learned a lot of physics, the interviewer said. I'm afraid not, I answered. Well, I expect your maths is of a high standard. I'm afraid not. Then, very doubtfully, I fear this job will often entail going out in the wet and cold in the dark. Would you mind that? Not at all. So I was taken on, and 10 days later set off from London with 19 other biologists on a mystery coach tour. So yeah, he joined the war effort, but because he had a science background, he didn't become a soldier. They wanted to give him a special science job. And he was put to work on radar systems because apparently at this point in the war effort, any sort of science degree qualified you to work on radar. He was first posted to the Orkneys, which are a wet, windy, remote group of islands off the north end of Scotland. And I gather David Lack was just about the only person happy to be sent there because the birding was really good. He got to spend all his off hours looking for puffins and skuas and stuff. But shortly after that, he was reintroduced to an old acquaintance of his name from Cambridge named George Varley, our third and final George of the evening. Again, it was a very popular name for scientists in this time period. George Varley was a classmate of Lack's from Cambridge. He had been an entomologist, an insect guy before the war, but again, apparently anyone with any science degree at all was being put to work on radar. And it was Varley who introduced Lack to the mystery of these so-called angels who were plaguing the radar operators. Now, Lack was an ornithologist by training. He was familiar with the behavior of birds in flight. He heard the description of the behavior of the radar angels and was pretty much right away like, you guys, it's birds. Nobody believed him. And so Lack and Varley decided to put their heads together to see if they could prove this. And they got pretty creative. At one point, they actually had an officer tie a dead gull to a balloon and send it up into the air in front of a radar station just to demonstrate that it was at least possible for a bird body to produce a radar signal. Finally, in September 1941, they managed to use a powerful telescope to confirm that the source of the signal being tracked offshore in real time was in fact a flock of gannets, the seabirds you can see here. As the war continued, Lack and Varley continued to collect radar observations that they believed represented birds. The technology was advancing by leaps and bounds, and so they pretty quickly went from only picking up big birds like gannets and geese to being able to detect things like flocks of starlings. Took them a while to convince everyone. There continued to be a lot of skeptics, and so I have one more brief David Lack quote just because I love his sense of humor. At one meeting, he wrote, after the physicists had again gravely explained that clouds of ions must be responsible, Varley with equal gravity accepted their view, providing that the ions were wrapped in feathers. So they stuck with it. Finally, in 1945, as the end of the war neared, they got permission to publish their findings, which had previously been top secret, in the journal Nature. Today, Lack, who died in 1973, is better remembered for a book that he wrote about Darwin's finches. But this publication, again, essentially kicked off the whole subdiscipline that's now known as radar ornithology. And radar ornithology might have been a footnote in my book instead of an entire chapter, if not for the fact that after the war ended, meteorologists adopted radar technology. Turns out that rainstorms show up on radar just as well as birds and planes do. And so pretty soon, weather scientists were putting up a whole network of radar stations as an early warning system for hurricanes and other major storms. Again, yeah, large flocks of birds showed up really well on weather radar. So putting up a nationwide network of radar stations was fantastic news for ornithologists. And over time, as advances in weather radar technology, like the introduction of Doppler, this has just made it possible to gather better and better information about migrating birds this way. So I have one quick research study that I want to describe that I just think shows the power of this kind of data. In 2018, two scientists downloaded radar scans covering every evening for the past 23 years, more than 150,000 individual radar images. And they analyzed them to see how weather factors like temperature and wind and air pressure predicted the appearance of big migration movements on radar. They found that their math, if you're paying attention, this is basically exactly the same thing that George Lowry and Bob Newman were trying to do with moon watching. It's just now we have much bigger data sets and we have computers to analyze them. So when they did this study, they found that their math explained almost 80% of the variation in how much migration was happening from one night to the next, which was pretty fantastic. And they discovered that they could even predict big migratory movements several days in advance this way. And so if any of you have ever used Birdcast, which is this amazing tool run by the Cornell Lab of Ornithology that gives you a forecast of how much migration is going to be happening in your area on any given night, this is the technology that Birdcast is based on. And it is all thanks to a witty science teacher from Devonshire who realized what was really going on with those so-called radar angels. But of course, radar is not the only way to put radio waves to work tracking birds. And this brings me to my third and favorite migration maverick of the evening. So this fellow's name is Bill Cochran. I do actually have a photo of young Bill Cochran. There he is on the left, and on the right, you can see him later in his career. In the mid-1950s, Bill Cochran was a young Navy veteran working on an electrical engineering degree part-time while also working for a brand new television station based in Champaign, Illinois. I told you I talked to some electrical engineers. One morning, young Bill Cochran went out to check on his employer's transmitter tower at the edge of town, and there was this guy there picking dead birds up off the ground. Cochran was intrigued, asked him what he was doing there. Turned out that this fellow was an ornithologist named Richard Graber, who worked for the University of Illinois, and he was studying tower kills, which is the phenomenon where flocks of birds fly into communications towers and are killed by the impact. Cochran thought this was pretty interesting and started asking the guy a bunch of questions. And pretty soon, Cochran was spending his spare time tinkering together gadgets to help Graber in his work. Excuse me. So Bill Cochran actually appears in more chapters of my book than any other single researcher. The first project that he and Graber worked on together was figuring out a way to record the nocturnal flight calls of birds flying overhead. They were actually the first guys to record these. And so one of my favorite little anecdotes from the whole book is Bill Cochran, the young engineering student, figuring out how to rig up a tape recorder, because this was the pre-digital era, with bicycle axles to hold the 6,000 feet of tape that they would need to record an entire 8-hour night of birds flying overhead. But the chapter in my book where Bill Cochran looms the largest by far is the one on radio telemetry. Radio telemetry just means transmitting data from one place to another in real time. And right around this time, there were two major technological advances that really got the field of radio telemetry going. The first was the invention of the transistor in 1947. Every time I give this talk, I joke that I am pretty sure that I'm probably the only person going around giving talks to Audubon groups with a photo of a replica of the first transistor in my talk, but here you go. So the short version of what a transistor is that before this, radios relied on bulky breakable vacuum tubes to amplify the signals that they sent out. They just weren't very reliable. Transistors provided a lightweight and efficient and durable way of doing the same thing. They're still the basis for all of our electronics today. And they made it possible to suddenly adapt radios for all sorts of tasks that they wouldn't have been suited for before, including transmitting all kinds of data from one place to another, so radio telemetry. One of the first organizations to actually jump on this and begin experimenting with it was the US Navy. The Navy right away started trying out ideas like using radio signals to transmit real-time data on a jet pilot's vital signs to someone monitoring them from the ground, and to transmit temperature data from inside a cold water suit during a test to see if it was effective for keeping sailors warm in the water. But it did not take long for wildlife researchers to begin borrowing some of these same techniques. I swear my whole book is just about ornithologists being really good at borrowing technological advances from other fields. So in 1957, some scientists in Antarctica used the system from the cold water suit tests to remotely monitor the temperature of a penguin egg during incubation. This is a photo from that study. I don't know if you can see it, but that's a penguin in the lower right-hand corner being manhandled. That same year, a group of researchers in Maryland borrowed some ideas from the Jet Pilot project and surgically implanted transmitters in woodchucks to follow their movements around a little nature preserve. Soon, big engineering firms like Honeywell were getting into this, trying to design radio tracking systems that they could sell to wildlife biologists to use to track wild animals' movements. But they were trying things like strapping a metal box containing radio components onto the back of a grouse and releasing it into the bushes. And a grouse with an awkward metal box strapped to its back does not last very long in the wild. So before wildlife telemetry could really take off, someone was literally going to have to think outside the box. I'm sorry, I couldn't resist the pun. And that someone turned out to be Bill Cochran. So I said two technological advances. The first one was the invention of the transistor. The second one was Sputnik. Yes, not only do I have a transistor, I also have an illustration of Sputnik. So this was, of course, the first artificial satellite. It was launched by the Soviets in 1957. Basically, all it did was go circle the Earth and beep. But if you had a radio receiver, you could pick up that beep from space from pretty much anywhere on Earth. And this touched off a whole new wave of enthusiasm for radio technology. And by 1960, Bill Cochran, who still had not actually finished his electrical engineering degree, but who was apparently something of a transistor savant, had picked up more part-time work, helping a University of Illinois radio astronomer build radio beacons that were going to be sent up on some of the first US satellites. Actually, they were some of the first US spy satellites, but Cochran and the astronomer didn't know that that's really what they were working on. Cochran was also still doing work for Graeber and his colleagues over at the Illinois Natural History Survey, and eventually someone suggested that they try combining Cochran's two part-time gigs. Why not? Hey, Bill, what do you think would happen if we put one of your radio transmitters on a duck? I don't know, sounds interesting, let's try it. So they sent a duck over from the field station on the Illinois River to the satellite lab. They strapped a transmitter onto this bird's chest using a metal band. And although they had not planned this, it turned out that the bird's breathing distorted the band in a way that affected the radio signal that they could track with the receiver. So when they released this bird, without even meaning to, they discovered that they had collected the first data on the vital signs of a bird in flight. And this moment, when this duck took flight, was basically the beginning of the rest of Bill Cochran's career. He was hooked, and he spent the decades to come doing nothing but building radio transmitters for wildlife, and he was really good at it. Building a radio transmitter to be worn by an animal in the field requires making trade-offs among a long list of factors, because a longer antenna will give you a stronger signal and a bigger battery will give you a longer lasting device, but they both add weight and you don't want to make it too heavy or it harms the animal. Cochran, who still would not officially finish that engineering degree for several more years, turned out to be really good at getting this balance just right. He favored designs that were as small and simple and compact as possible. And instead of putting components in a metal box, he came up with the idea to just dip the whole assembly in plastic resin to seal and waterproof everything together. And he didn't just work on birds. We're all familiar with the idea of like radio collars for wolves and deer and stuff like that. Basically, the whole field of wildlife telemetry all goes back to Bill Cochran. He is the guy who first made all of this practical. But he definitely had a special interest in birds because of his early friendship with Richard Graeber. And it didn't take long before Cochran was building transmitters so small that they could safely be placed on large songbirds, which is great news for his friend Richard Graeber. Graeber was a thrush guy. He was particularly interested in the migration of thrushes, which are a large songbird. And so Graeber wanted to figure out a way that he could use Cochran's devices to actually follow a thrush during migration. These devices only had a range of a few miles, so if you wanted to use one to follow a migrating bird, you literally had to follow the migrating bird. So Graeber actually found a pilot who was willing to take him up in a plane to try following along behind a migrating radio tagged thrush at night. This is the plane there. You can see all the antennas sticking out of the back of it. So in May 1965, they captured a gray-cheeked thrush outside Urbana, Illinois. They trimmed the feathers from a little patch on its back, and they stuck on a transmitter using eyelash glue. This is a total digression, but if you'll forgive me, yes, eyelash glue, the same stuff you use to attach false eyelashes. It's still very popular for this because it's non-toxic, doesn't irritate the skin, wears off on its own after a while. And I just love the mental image of generations of crusty macho wildlife biologists having to learn where the eyelash glue is at the local cosmetic store. Anyway, that night, Graeber and the pilot followed this bird north for 400 miles before they turned back, 200 of which were over the open water of Lake Michigan. It was dark. They wouldn't have been able to see the bird. They were just sitting in the cockpit, flying through the night, hearing the sort of wavering beep, beep, beep of the bird out ahead of them somewhere. And Graeber was so awed by this experience and by what this bird was doing that when he wrote about it later, he compared it to the emotions that he felt watching the TV coverage of the Apollo moon missions. And Bill Cochran, the engineer, he was just getting started. The Bill Cochran stories that I'm telling in this talk, they barely scratch the surface. Every time I give this talk for an audience of ornithologists, I hear more Bill Cochran stories that I have not heard before. The guy was amazing. In 1973, Cochran and a student named Charles Welling tagged another migrating thrush passing through Illinois in the spring. And this time they spent a full week following behind this bird, almost 1,000 miles, all the way across the Canadian border and into Manitoba in a station wagon with a hole cut in the top for their radio receiver, which you can see here. I read the very dry 2-page scientific paper describing this expedition and my jaw just dropped. I couldn't believe that someone had done such a thing. And although these didn't make it into their dry 2-page paper, they had some adventures along the way. At one point, the student who was along for company and to help drive basically spent a night in jail when a suspicious police officer pulled them over in rural Minnesota, because who wouldn't be suspicious seeing this thing drive through your town in rural Minnesota in the middle of the night? Cochran didn't want to stop for very long because he was worried he would lose the signal. So he basically kicked the student out of the car to sort things out with the cop, kept on driving, waited until the bird set down at dawn, doubled back, bailed the student out of Minnesota jail, and then kept on going. At another point, apparently they got the stomach flu and couldn't find a doctor in the middle of nowhere to see them on no notice. So they just kind of sweated it out and kept on going. As they went, they gathered data on the bird's altitude, its airspeed and ground speed, the distance that it covered each night, its heading. And because they were able to stick with the bird over such a long distance, they were actually able to track how the precise direction that the bird set out in each night changed as its position changed relative to magnetic north. And the gradual changes that they saw in its heading were consistent with where magnetic north was, and this provided some of the first real-world evidence that migrating birds use some sort of internal magnetic compass as one of their tools for navigation. They probably would have kept on with this even longer, except they were finally forced to stop when the car's engine gave out shortly after they crossed into Canada. Cochran never really got the hang of the politics of academia or of the peer review system for scientific publishing. He published some of what he did in scientific journals and some of it in hobby magazines for falconers. He never quite got that down. He really always remained a bit of an outsider. Remember, he was an engineer by training, not a biologist. And I also gather he might not have been the easiest person to get along with personally. He was, married several times, that sort of thing. By the late 90s, he had left the Illinois Natural History Survey on what I gather were less than good terms, but he kept building radio systems for ornithologists in his garage right into the beginning of this century. I had the great good fortune to speak with Bill multiple times while I was researching my book, and I even got to visit him at his home in Illinois, where most of his backyard was taken up with an enormous radio receiver tower, and this station wagon was still in the driveway. He was a character. He would screen his calls by pretending to be a janitor in an animal shelter when he answered his phone. So I would call him at a prearranged time for a phone interview, and he'd pick him and go, "Hello, animal shelter, we're closed." And I'd be like, Bill, is that you? He was a hoot. Sadly, he passed away last year at the age of 90. I really believe that he is an unsung hero of 20th century science, and I'm very happy that my book is hopefully making more people aware of all the things that he accomplished. So I'm coming to the end of my talk here, I promise. In my last 2 minutes, I want to talk a little bit about the concept of migratory connectivity and why all of this matters. I do want to say I chose historical stories for this talk on purpose, partly because, as I mentioned, I have given this talk for audiences of ornithologists, and it felt weird to maybe be talking about someone who would be in the audience. So if you get a chance to read the whole book, I promise not to put too fine a point on it. I promise the book is not all dead white guys. So you'll meet a lot of cool women and people of color who work in this field as well. And I also in the book cover a lot of the more recent developments in this field, like the latest miniaturized tracking devices and artificial intelligence tools for analyzing big data sets and high volume genetic sequencing, all that stuff. And thanks to all those recent high-tech advances, we now have a clearer and more detailed picture of bird migration than ever before. This data can help us target conservation efforts more effectively, and that's a good thing, because migratory birds are in trouble. I'm sure some of you are familiar with what's been called the 3 billion birds paper, which is this study from 2019 that found that there are 2.9 billion with a B fewer breeding birds in North America now than there were in 1970, which is almost a 30% decline. It's just staggering. Researchers and wildlife managers have been scrambling to figure out how to stop the bleeding. And when it came time to write the conclusion for my book and try to tie a bow on the whole thing, I wanted to tackle the question of whether some of these new migration tracking technologies might be part of the answer, and just whether there's any reason to feel hopeful. And so one of the things I did was get in touch with a couple of the leading experts on migratory bird conservation in North America today and call them up and ask them what they thought. So I talked to Pete Mara, who's one of the senior authors on this paper and co-founder of the Road to Recovery initiative that grew out of it. I also talked to Jill Deppy, who's the director of the Audubon Society's Migratory Bird Initiative. And they were both very kind to let me call them up and ask them laughably broad questions like, what is the state of migratory bird conservation today? Which is a horrible, too broad of a question. And are you hopeful for the future? And they really had strikingly similar things to say. They agreed that despite all the ever more detailed migration research happening now, we still need more data to understand what's behind the declines of many of these species. We still don't know enough about what's going on. They agreed that there is a need to better consolidate the data that is being collected and get it into the hands of policymakers and conservation activists to work across borders, to incorporate more partners in the social sciences, more perspectives from Indigenous people. And somewhat to my surprise, they both insisted that yes, there is still a reason for hope. Excuse me. So to conclude, I'm going to read a little bit of what Pete Mara said to me when I asked him if he feels hopeful about the future. He said, "I'm very optimistic. We've done this in the past. We've corrected other environmental issues, and now we have to deal with climate change. So while it seems like there's this overwhelming deluge of negative issues and challenges with getting people on board with these things and constant pressures on nature, I choose to be optimistic and hopeful just because I don't see any benefit of being pessimistic or having a lack of hope. I just don't choose to take that route. Don't get me wrong, there are times when I might be negative or spiraling down into a pit of agony, but I'm not going to do that." I thought those were wise words. And I don't know about all of you, but when I find myself spiraling down into a pit of agony, I usually just go birding. So that is what I've got for you this evening. I want to thank you folks at Kitsap Audubon for inviting me. If anyone who has not read my book is moved to go out and buy a copy after hearing this talk, I obviously can't sign copies in person since I'm not there. But if you go to my website, which you can see here, there's a contact me form, and I would be more than happy to drop a signed book plate in the mail for you. I also, if you go to my website, I have a monthly email newsletter you can sign up for where I share other things that I'm writing and book recommendations and links to interesting bird news from around the web, that sort of thing. The stories that I've told this evening are really just scratching the surface of everything that's in the book. So I hope some of you get a chance to read the whole thing, and I'm happy to take some questions.
Love to start first. That's right.
Yeah.
Oh, can you hear me? Oh,
yes.
Well, I was just gonna say, traditionally in in-person meetings, after the presenter speaks, we all applaud. I don't know how that sounds from here, but
I heard you. Yeah.
Thank you so much. One question I had was, you must have come across all sorts of crazy bird migration facts. I love seeing stuff just randomly about this bird that can fly for days and days and days without end.
Yeah.
What is your favorite bird migration facts?
My favorite one, I think, is the blackpoll warbler. I mentioned these are the guys that make the 3-day nonstop flight over the Atlantic Ocean to get from New England to South America. What's really amazing, and I'm sorry if some of you know this already, but there are blackpoll warblers that breed in Alaska. And so what those ones do is they cross the entire continent from west to east, first going from Alaska to New England, And then they spend 3 days flying over the open Atlantic Ocean. So it's just mind-boggling that a bird about that big does that.
Thanks.
Yeah.
So once again, if you have a question on the Zoom, go ahead and put it in the chat, or you could raise your hand and we can call on you. I don't see any in the chat right now, so I'll go back out here. Any questions in the room? Question over here.
Are there significant numbers of birds that do take the sensible route and migrate north through Mexico rather than flying over the Caribbean?
Gosh, that's a really good question. I'm trying to remember. I think there are some, but I think sort of the most common thing really is the flight over the Gulf of Mexico. Hummingbirds fly over the Gulf of Mexico. It's just astounding.
Can I comment on that?
Yeah, someone else there might know more about that than I do.
In my ornithology class in college, we talked about this.
Okay.
The determinations that I was taught was that essentially it comes down to a matter of body. So those birds that had a high enough body condition that they could make it across the Gulf, fly across the Gulf, because they got to their breeding grounds, submerged early. Those that were not
22 participants.
went all the ground, sometimes arriving at a month, 6 weeks later.
Thank you. Yeah, I didn't have that information at my fingertips, so I appreciate that.
Well, great. So Millie in the chat said, thanks for a great talk. No question, but thanks.
Thank you.
Yeah. Any other questions here? Or? One more.
Just one thought that crossed my mind when you were talking about the 29% decline in birds across North America, and I just heard echoes of Silent Spring.
Yeah.
I'm thinking how prophetic that book is.
Yeah.
Ways.
Well, the biggest sources of mortality today are habitat loss, cats, and window collisions. And I think climate change is going to be moving up that list in years to come.
So we do have a question in the chat from Justin asking, how much of an impact do you think citizen science, such as eBird, is having on our knowledge?
The answer is a lot. There's these products called eBird Status and Trends, and I talk about this in the book, where they have these incredibly fine scale, detailed range maps where you can just sort of see how the concentration of birds shifts across the globe over the course of the year. And now they're also adding to this trends over time to see whether specific bird species are increasing or decreasing, all with eBird data. And then there's also the spring breeding bird census, the roadside one, which I also talk about at length in my book, which is another citizen science project, which is pretty much the source for long-term population trends for North American birds. And it's all citizen science. So every time you use eBird, you are having an impact.
Rebecca, I have a quick question.
Yeah.
You were showing an example of where one of the researchers put a radio out there, or a microphone to record the calls at night.
Yes.
So could you explain a little bit more about how that worked? Was he able to distinguish those birds? What sort of techniques did he have to do? Is it just listening by ear, or were there other tools that were used to determine the birds?
Yeah, so they successfully made the first recordings of these birds passing overhead at night, and they were able to do some things with that data. It was pretty challenging when they were doing this work in the 50s, because once you had an 8-hour recording, you then, there was no computer to help you analyze it. You then had to sit there and listen to 8 hours, and, you'd have long stretches of silence, and you'd be listening for little bird calls, and then you'd have to stop and rewind and try and figure out what they were. And so they tried other things like rigging up their recorder to take like a 1-minute sample every 10 minutes. They did all sorts of things to try and make this more manageable. They were able to use that data for some things, just to kind of look at how the volume of migration varied from night to night. It was another fellow who came along sometime after that named Bill Evans, who kind of was the first person to really drill down and fully figure out which calls went with which species, because a lot of these nocturnal flight calls are totally different from the calls that the birds give during the day. So there's a lot of more work that's been building on that since then. And now they're working on, you know, artificial intelligence to pick out and identify these calls to make it a lot easier. There's a whole chapter in the book about that.
Thanks. There's a couple, one comment and a couple questions in the chat. So Judy said, thank you. We enjoyed your talk. And
Thank you.
Isabella is asking, what was your latest lifer or most recent bird you've seen for the first time?
Ooh. What was my most recent lifer? Oh gosh. Oh, I know, yellow-billed magpie. I was just in Central California in November to give this talk at the Central California Birding Symposium. And I realized like 2 days before I was flying down there that I was flying into yellow-billed magpie territory. And so when I got there, I mentioned to my host that I was really hoping, I was there for all of 48 hours, and I mentioned that I was really hoping to see a yellow-billed magpie. And so birders being birders, they made it their mission to make sure that I saw a yellow-billed magpie before I got on the plane to come back home. And I love corvids, so it was great.
Right, and Jean and Sandy had said that in New England, when they lived there, they had mixed feelings about the black-polled warblers because they signaled the end of their migration.
Oh yeah.
Migration of the warblers. And Justin asked, I have an eBird to help me remember that. Yeah, it's a lot of going back and forth. Isabel said, no way, I'm from the Bay Area and just saw them while home last fall. So, like we have a question in the back here.
Okay.
So, got two questions for you.
Okay.
First one is, how accurate do you find Cornell or others AI generated AI song identifications?
I cannot speak in great detail to how accurate they are for nocturnal flight calls. I believe those are still in development. I will say that I am an avid user of the Sound ID in the Merlin app for just everyday birding, and I found it to be very accurate and very helpful. It comes up with some weird stuff every now and then, so you have to apply some critical thinking, but overall it's very useful.
Thanks. The other question is, do you have any other recommended further reading this kind of subject?
Oh gosh, that's a great question. I mean, I'm sure a lot of you are already familiar with Scott Wiedensal's latest book. That's a pretty good companion for mine because he kind of goes into the migration itself and the wonder of migration, and actually some of the same people that appear in my book appear in his book, but then mine kind of goes into the science underlying all of the stuff that he was talking about. So that would probably be my top recommendation. I'm sure you've all read it already, though. It's really good.
Yeah.
I'm not seeing any hands in the room. And not seeing any more on the chat. Really appreciate your talk today, Rebecca. And once again, we'll have this recording up on our website so others can see it if you want to re-look at it. And we'll also put information about how they could get access to your book.
Great, thank you.
All right, well, thanks a lot for coming. Happy holiday.
Thank you. Good night, everyone.
Bye
Thank
now.
you.
Just a bird.